Hello everyone, welcome to new class. Let us study about operational amplifiers. In short, op-amps. So, what is operational amplifier or op-amp? Op-amp is a linear IC. IC means integrated circuit, and it is used to amplify AC and DC signals. So, it is used to amplify AC and DC signals. And within a certain input range, the amplification curve of a linear IC is a straight line. That is, the input and output voltages are directly proportional. And it is also used to perform mathematical operations such as addition, then subtraction, multiplication, then division, differentiation, then integration, etc. And it is also used for oscillators, then filters, then regulators, then clipping circuits, then waveform generators, etc. So, op-amps are used for the mathematical operations like addition, subtraction, multiplication, division, differentiation, then integration, etc. And also used for the oscillators, filters, regulators, clipping circuits, and waveform generators like that. Next is symbol of op-amp. So this is the symbol of op-amp, and it consists of two input terminals, one output terminal, and two bias supply terminals. So this is the symbol of op-amp, and here the negative terminal is called inverting terminal, and positive terminal is called non-inverting terminal. A is the voltage gain, also called the large signal gain. And here V0 is in phase with V1. V0 is in phase with V1, so called the non-inverting terminal. And the output V0 is 180 degree out of phase with V2. So V0 is 180 degree out of phase with V2, that is negative terminal, hence called the inverting terminal. So V0 is in phase with V1, that is the positive terminal voltage, so called the non-inverting terminal, and V0 is 180 degree out of phase with the negative terminal, that is V2, negative terminal voltage V2, hence called inverting terminal. And here V0 is equal to A into V1 minus V2. A is the voltage gain. That is, the output voltage is equal to the voltage gain times the difference of the two input voltages. So, output voltage V0 is equal to voltage gain times the difference of the two input voltages. Next is ideal op-amp characteristics. So these are the op-amp characteristics. In ideal op-amp, input resistance, that is Ri, is equal to infinity, Then output resistance RO is equal to 0. Voltage gain AB is equal to infinity. Bandwidth is infinity. CMRR, that is common mode rejection ratio, is infinity. Slew rate is infinity. Zero offset. That is when V1 is equal to V2, output voltage V0 is equal to 0. So these are the ideal op-amp characteristics. So output resistance and zero offset are 0 and all other characteristics are infinity in the case of ideal op-amp. Let us study about op-amp parameters. First one is input offset voltage. And in op-amp, the difference of the input voltages is multiplied with the gain A, and which is the output voltage V0. That is V0 is equal to A into V1 minus V2. And it is found that the output voltage may still not be 0 with 0 input voltage, and this is due to unavoidable imbalances inside the op-amp, and one may have to apply a small voltage at the input terminals to make the output voltage 0. This is called input offset voltage. That is, the voltage required to be applied at the input for making the output voltage to 0 volt is called input offset voltage, and it is denoted by VID. That is, difference in input voltage is applied at the input terminals. So it has two input terminals. So input offset voltage is denoted by the letter VID. That is difference in input voltage. That is input offset voltage. So it is the voltage required to be applied at the input for making the output voltage to 0 volt. Next is input offset current. It is the difference between the two input currents, that is denoted by I, is equal to IB plus minus IB minus. That is, IB positive is the input current at the positive terminal. So IB positive, it is the input current at the positive terminal, and IB negative, it is the input current at the negative terminal. So input offset current is the difference between the two input currents, and the smaller the input offset current, the better is the op-amp performance. The smaller the input offset current, better is the op-amp's performance. And for the 741 IC, the input offset voltage is about 2 millivolt, and this input offset current is about 20 nanoamperes for the 741 IC. Next is input bias current. It is the average of the currents that flow into the inverting and non-inverting input terminals of an op-amp. That is, IB is equal to IB positive plus IB negative divided by 2. That is, IB positive and IB negative are the two input currents to the op-amp, and its average is called input bias current. And for the 741 IC, its value is about 80 nanoamperes. Next is common mode rejection ratio, that is CMRR. It is defined as the ratio of the differential voltage gain AD to the common mode voltage gain ACM. That is CMRR is equal to modulus AD divided by ACM. That is the ratio of the differential voltage gain to the common mode voltage gain. Then what is AD and ACM? AD, that is the differential voltage gain AD, is the gain of the op-amp when two different voltages are applied at the two inputs, and it is same as the large signal voltage gain A. So AD is same as A. Then what is ACM? That is common mode voltage gain ACM. It is the gain of the op-amp when the two terminals of the op-amp are applied with same voltage from the same source. And generally AD is very large and ACM is very small. So for the 741 IC, CMRR is equal to 90 dB. dB means decibel. So this is common mode rejection ratio. Next is slew rate. It is defined as the maximum rate of change of output voltage. That is dV0 divided by dt maximum. And for the 741 IC, its value is 0.5 volt per microsecond. That is unit is volt per microsecond. Then next is input resistance, and it is in the range of 100 kilo ohm to 1 mega ohm, and output resistance, it is in the range of 40 to 100 ohm. Next is equivalent circuit of op-amp. So this is the equivalent circuit of an op-amp. This circuit includes the values of open loop gain A, then input resistance Ri and output resistance Ro, then the voltage source AVID. That is, it is the equivalent Thevenin voltage source, and Ro is the Thevenin equivalent resistance looking back into the output terminal of an op-amp. So here V0 is the output voltage, and that is equal to A into VID, that is A into V1 minus V2. A is the large signal voltage gain, VID is the difference input voltage, V1 is the voltage at the non-inverting terminal, and V2 is the voltage at the inverting terminal. And plus VCC means we are applying positive bias voltage at this terminal, and here minus VEE means we are applying the same minus voltage at the minus bias voltage at this terminal. Next is ideal voltage transfer curve. So here the output voltage is directly proportional to the input difference voltage only until it reaches the saturation voltages, and thereafter the output voltage remains constant. So this is the ideal voltage transfer curve, and this is the pinout of 741 IC. So here 2 is the inverting input, 3 is the non-inverting input, then 4 is the minus VE, 7 plus VCC, then 6 output. So this is about the basics of op-amps, that is operational amplifier. So in the next class we will discuss more about op-amps. Then thank you for watching the class. If you like the classes, please like, share and subscribe my channel.